Okay, today we have the corrections for the class test on the speed time, distance time. Okay, first, question 1a. The van accelerates at 0.88. If you notice, this is a speed time graph, so therefore 0.88 actually gives the gradient at t equals to 20. So if t equals to 20 is somewhere here, it means that for the entire line, the gradient is actually 0.88. So this gradient of this portion here is equals to 0.88. How do I obtain the gradient here? We just go for rise over the run. The rise here will be v minus 20. My run here, 40 minus 15 is 25. So for part A, I can write v minus 20 over 25 give me the gradient of 0.88. Can so far? Then the rest of it, right, is basic solving. 0.88 times 25 will give me 22. So v minus 20 is equals to 22. V is equals to 42. Simple enough. 42 meters per second. Next part. Calculate the average speed of the van. Average speed will be total distance over total time. So let me write that. Okay, total distance traveled, we have to do it step by step here. Okay, total distance from a speed time graph can be achieved by finding the area underneath the graph. So in this case, the area underneath the graph, for this part, 20 times 15 will give me 300. This portion here is a trapezium. So we have a plus b over 2 times height. So it's a plus b, 20 plus 42 divided by 2 times the height of 25. This portion here will be 775 meters. This portion here is half times base, which is 20, times my height, which is 42. This portion here is 420, like this. So my total distance is 300 plus 775 plus 420 is 1495. My total time is 60. So 1495 divided by 60 is 24.91. 60, 1440, 1440, 55, 60, 11 upon 12. Okay, 11 upon 12. Okay, 24 and 11 upon 12. I don't have a scientific calculator, that's why it's taking me a while to figure these things out. But it's 24 and 11 on 12. We can leave it as mixed number. It's the most accurate. That will be the best. That's why I was taking some time there to try to figure out the value there. Okay, now next part here, the distance time graph. Speed is constant. Distance time graph should have a steady gradient. So steady gradient, let me try to find a ruler. Okay, so it should go upwards like this as a straight line. Okay, because if you notice here, the gradient, constant speed means constant gradient for distance time graph. And don't forget to label the distance. This should be 300 meters. Why 300? Because first 15 seconds you travel 300 meters. Excuse me. Next one, 15 to 40. Speed increasing. Speed increasing means the gradient of the distance time graph should be increasing. So down here, what I should do is I should draw something like this. Notice that it is a curve like this, and don't forget to label the distance at the side there. The distance, if you notice, this is 300 plus 775 will give me 1075 now here. And lastly, decreasing speed. Decreasing speed means decreasing gradient. So if it's a decreasing gradient, it should be a curve like this. Okay, so this portion here, and don't forget to label the final distance that they will reach will be 1495 meters. So you have to know that this part here is a straight line, okay, constant gradient. This portion here is increasing gradient, and this portion here is decreasing gradient. And many of you forgot to actually label these distances here by the side. Alright, Next question we have is this: find the volume of the container, leaving your answers in terms of pi. Okay, so the volume is simply equals to the area of cylinder, which is pi r square times height plus area of the volume of the cone, 1/3 pi r square, which is 4 square times height. Okay, in the end you should get 448 over 3 pi. Many of you did not leave this in mixed number. Okay, it's an improper fraction. You should not leave it as 149 and 1/3 because of this pi here. So you write it as improper. So what you should get is 448 over 3 pi cm cube, like this. Then we go for part B. 56 seconds to fill up the entire container. If you notice down here, right, this is one of this. This is, okay, pi times 4 square times 7. Here's pi times 4 square times 7. If this is 3 parts, this will be 1 part. So the volume of cylinder, okay, to the volume of cone. I repeat, this 4 square 7, pi 4 square 7, pi 4 square 7. This is 1 part, this is 1/3 part. So for volume of cylinder is to volume of cone, the ratio is 3:1, like this. So if it's 56 seconds to fill the entire container and 4 parts is the entire container, and I want to fill just the cone is 1 part, so I just take 56 seconds, okay, divided by 4. Okay, I will take 14 seconds, right, to fill the volume of the cone. And this one actually is quite simple. If you know the trick to it, now you know. Alright, and now last part here, water is poured into the container at a constant rate. Using the axis below, sketch the height of water. So basically it will fill up the cone first. Notice the bottom of the cone is small, while top it gets bigger and bigger. So that means, right, the water will be filling up, right, at a decreasing rate. So first part here, it should be a decreasing rate like this. So at first the gradient will be quite steep, then it becomes more gentle because, right, top part here, the height of the water will be decreasing more slowly. Next part here, constant cross section, it will mean that it will fill up at a constant rate. So if it fills up at a constant rate, okay, the height will be increasing at a constant rate. All you do is to take a ruler and to draw it, and you are done with the corrections for this test. Thank you for watching.